everybody. Welcome to Dana and Garrett's, or Mom and Garrett's, new lab challenge. This is our very first video, so we're going to learn as we go. This is a brand new book that we bought to do in-home labs. It's called Awesome Kitchen Science Experiments for Kids by Megan Olivia Hall. 50 STEM projects that you can eat are in this book. So we're going to start today with one that is listed as the difficulty level is easy. It's called Crunchy Caterpillar Action. Color Change Celery. It has a minor mess. You can eat it at the end. It takes very little time to put together. And the full time to set up is 35 minutes today, and then we're going to have to go overnight and let it percolate. And we'll just have 5 minutes on day 2. And in the end, you get 2 crunchy celery sticks. First, we're going to go through what we pulled for our ingredients. According to this lab, the tools we need are 2 tall glasses, which we have, a knife that the book says you'll want an adult to cut, but we already bought kids' knives. So if you're a kid, you want to do all of this on your own, these are super easy to use kid knives that you could use yourself, maybe with a parent in the room. Or maybe you're already using big knives. Then the ingredients we need is food coloring. We'll be using blue and 2 celery stalks. We'll put that together. And that.
Make sure to like and subscribe for more.
Okay, water is the most important molecule in living things. On a hot day, plants lose water through their leaves. They make up for the lost water by taking water from the ground through their roots. The water moves up through plants, defying gravity. In this experiment, you will observe this amazing water movement called capillary action. Do you think capillary action works better in plants that are dry or plants that are wet? Garrett, what do you think?
I don't know.
I guess we'll find out in the end, right?
Yeah.
Okay. It does say caution in the book, have an adult use a knife to cut the celery. But like I said, if you have your own as a kid, you could probably do that by yourself. Maybe even do the whole lab by yourself. But this is our very first lab out of this book. We're going to work on it together. All right, so I think what we need to do first, Garrett, is decide our hypothesis, our observations, and our results. And let's just talk about it, because first we're going to do the hypothesis before we actually do the lab. Because what is a hypothesis? It's what do we think is going to happen, or the prediction of what we think is going to happen at the end of our experiment, right? In any experiment, scientists have to decide what might be the end result. So that's what it is, a hypothesis. The book says, hypothesis, predict whether you will see more capillary action in wet or dry celery. And you already said you're not sure. So we're going to just say, we're not sure. And write that in the book on the lines provided. Okay, and then as we're going through the process of our experiment, we'll observe, and then at the end tomorrow, we'll see the results, and we'll finish filling out this side of the book, where we'll put all of our indications of our experiment. Okay, so the steps. We're going to start on our steps right now. Jumping right into the lab. We've done everything. We've read about it. We've gotten our ingredients and our tools, and we've written our hypothesis. And we feel like real scientists, right?
Yeah.
Okay. Step 1 is to fill 2 tall clear glasses with water. Pretty good on the water levels. Let's see, I eyeballed that really well. Okay, that was step 1. Step 2 moves to put 4 drops of food coloring in each glass. Do you want to do that? You can just squeeze 4 in each. Okay, step 3 wash 2 long celery sticks, which we already did in preparation. 4, have an adult use a knife to cut the bottom 2 inches and the top 3 inches off each celery stick. Okay. So we have to do a little bit of our measurements. You know, if we had a ruler or we have a ruler in our mind, then we would either get a ruler or we would use our mind's ruler, right? An inch is about that big. So on the end, this is the end, because this was where it came from the root when we took it from the package. 2 inches off the top. Why don't we do the bottom first? Because we know we already broke off a bad spot on this one. So we know where the top is, we just don't know where the bottom is. Okay, so now we need 3 inches off. Wait a minute, what did I say? Cut the bottom 2 inches and the top 3. So let's do 1, 2, 3. Good. All right, and then we'll measure it out. That one right there, and try to measure it out. Okay, now we're going to try and do it right there, just like that. All right, those out of the way. And then we need 2 inches off the bottom. Yeah, about right there. We want it to have fair chances. Okay, match it. Crunchy. All right, step 5 is place 1 celery stick into a glass of cold water immediately. Okay, I guess it doesn't matter which end. Cold water immediately. There should be at least 2 inches of celery sticking up. Oh yeah, we got plenty. Above the water. Set the other celery stick on the counter to dry for 30 minutes. Okay, so we have to set the timer for 30 minutes for this poor guy. He's gonna dry out and lay here for 30 minutes. This one we cut and he is already in water immediately as it said to. I think we're gonna stir it a little bit. Okay, set the other celery stick on the counter to dry for 30 minutes. And then after 30 minutes, we're going to place the second celery stick in the second glass of cold water. There should be at least 1 inch of celery stick up above the water, which we will have plenty. And then you will let them sit overnight. We'll come back in 30 minutes, put the dry guy in the second glass, and then we will be back tomorrow.
So we are back, and it's been 30 minutes, and now we will put this into the blue one and stir it a little bit, and then we will see you tomorrow.
Bye.
Then the next day, and the treat's is done.
Okay, so yesterday we went through and put the food coloring in 2 glasses of water, and if you remember, this one is the one that had to sit out for 30 extra minutes and dry out before we could put it in the water. This is the one that we cut the ends off, like our lab told us to, and then we stuck it straight into the water. And what we see today, do you want to move up so we can get a closer look? We have to observe or describe what you see after the celery has soaked overnight. So if this is the one that was dry and this is the one that was wet, Garrett, what do you see more of?
Blue.
Yeah, in the wet one. The blue is more in the wet one than the dry one. So I put food coloring. Rose up more in wet celery. And the results, did the wet celery or the dry celery have more capillary action? Well, we just kind of answered that. It was the wet. All right, to sum up this entire lab in this book, the hows and whys. In the wet celery stalk, water evaporated out of the top of the celery. New colored water came in from the glass to replace the water loss. So this was the wet one, and that's what it's explained to us, that our lab worked exactly as it should have, because the water was evaporating out of the wet celery to make room for more water, the blue food colored water, to come to the top. And that's what we're seeing. Unlike most chemicals, water sticks to itself well. The water that was already in the celery stuck to the colored water in the glass and helped pull it up using capillary action. So that's this one, and it is doing exactly what it was supposed to do. The wet water that was in it when we cut it and stuck it immediately into the glass of food coloring, the water that's there brought it up to the top. Dry celery has bubbles of air in the water tubes. So this is our dry celery, and that's what it's saying, is we dried it out for 30 minutes as the lab told us to, and it had no water for the molecules to drag up to the top. In the book, dry celery has bubbles of air in the water tubes. The bubbles of air stop the capillary action. So the water that was existing in the celery stick, helped draw new water to the top, and this one had air bubbles in its capillaries, which the capillaries are inside the stalk. Stem connection. Capillary action is a big part of agriculture. Agriculture scientists and engineers have to understand how to keep plants watered in order for food crops to grow. And of course, agriculture is like farming on a big scale, like all the corn stalks and all the fields of corn, the bean plants and that sort of thing, potatoes, everything. And the book says, turn it up. Capillary action can also be used to add food coloring to flowers. Find a pesticide-free white rose and soak it in a mixture of food coloring and water overnight. You can eat the colorful petals on a salad the next day. I don't know if I'd try that, but what do you think? You would? We might have to try that one day. Keep checking back. You never know when we'll do that. Thanks for watching.
Bye.